I will talk about the larger flexible electronics by laser processing, and I will take the chance to present our new lab situated in the 4th floor of S building. And I'm really glad to present the work of photonics and detector group since in 2015, since 2015 is the year of the International Year of Light and Light-Based Technology. Well, after a brief introduction about the progress of the printed electronics and the motivation of our work, I will describe the laser processing of silver nanoparticles and graphene oxide, and at the end the summary. In this busy world, the great development of nanotechnology, biotechnology, ICT and sensor technology needs to be the primary research to make our life easier. Imagine if the cartoon of our milk could send us a message warning that the milk is starting to spoil, or the wallpaper could change color depending on the weather, making in this way even a rainy day nicer. This is possible by substituting the traditional electronic by the flexible large area electronics production. And this is possible by incorporating the information in the paper-based product, used in different applications such as sensors, supercapacitor, OLED and solar cells. Our objective is to develop methods for the production of large area electronics, which need the use of the building blocks for electronics like conductive materials, semiconductor and isolator. These methods needs to be cost-effective, to use flexible substrate, and so compatible with roll-to-roll manufacturing, and in the same time fast, selective and non-destructive process. So compatible with all the requirements we show in the previous slide is a promising technology, is the laser technology. So the laser processing, this is a video when I will show the laser processing of the materials, which is easily controlled via computer and offers us the freedom of any kind of patterns with a resolution down to microns. For now, we are developing our investigation in the lab scale area, but where the scanning area is 10 square centimeter. But this can be easily scaled to a large area. This is just one example of one pattern that we use in the laser, in the lab. We developed and we're developing different lasers which offer a continuous and pulse mode, offering different power levels and different wavelength, which offer us the possibility to process a large area of range of functional materials. And this is one of the cases that we used. This is a silver inkjet printing RFID tag, where after printing the conductive electricity is very low. Therefore, we use the laser to process and to increase the electrical conductivity. Well, simply explaining the physical process during the laser processing, that has to be with related with the evaporation of the solvent in the ink and the coalescence of the silver nanoparticles, which give an increasement of an improvement of the conductive electrical conductivity. So in order to have the optimal value of the conductivity of the film, this needs a really high temperature process that is really difficult to be compatible with a paper-based substrate. So we really believe that laser technology is really promising to process these nanoparticle thin films, and so to do it in a non-destructive way, so without damaging the substrate. In the case of graphene oxide, which is a really good insulator, we laser processed and we transform it to reduce graphene oxide, which is a good conductive material. So as it is depicted in the figure, what happened is we can have, or we can design any kind of conductive pattern with our software, with the laser, making it conductive, still maintaining them isolated with from each other, since we use the properties that the graphene oxide offer. So, we truly believe that the laser processing is a promising method for large area paper-based electronics, and the good result that we have achieved in processing silver nanoparticles, thin films and graphene oxide inspire us to continue with other functional materials. Thank you.